Okay, so let's identify the missing piece here. So it's going from 92 to 90, and the arrows here. So remember the law of conservation of mass. So if it goes from 92 to 90, that 2 has to be somewhere. So that means there's going to be a 2 on the bottom. Same thing's true with this. It's going to be 4 on the top. And what is that? What element is 2? It would be helium. So this would be an example of alpha decay or alpha radiation. Okay, let's take a look at this one. So for this one, it tells you the particle over here, but it doesn't tell you what it's going to become. So if it's at 88 and it loses 2, that means it's going to be 86. And then if it's at 226 and it loses 4, it's going to be 222. Okay, so for this one, it's going to be it's Ra. It's going to lose 2 to become Po because 86 is polonium. All right, now what kind of radiation is this? Also alpha. All right, and finally, identify the missing piece here. All right, so now we have this -1, which is our beta, right? This means the same thing as -1 beta. All right, so it's beta radiation, so let's write that down, beta. Okay, so it's 53, and then we have this -1 here, which means it's going to be 54. Because if you combine these two, 54 and -1, you'll end up with 53. Nothing happened with the top, so it's going to still be 131. So now we look up 54 in the periodic table, and we see that it's xenon. So that would be our answer for that one. All right, here we go. Carbon 6. We have carbon 6 and 14, and then it becomes nitrogen 14. All right. So what's happening here? What's going to make it go from 6 to 7? We need a -1 down here, right? Because 7 plus -1 gives us 6. So what particle was -1? Well, we just saw it. It's going to be, you can put a little beta here, or you can put the -1e. Either are fine. This is beta decay as well. All right. So that hopefully makes a little bit more sense, where it's 7 plus -1 gives you 6. All right. All right. Identify what's going on with this one. So we have 56 here, and then it goes to barium, which is still 56. And then the 137, 137. So it looks like nothing happened, right? So that means that it's going to be gamma. Now we know that there is radiation because of the squiggly line, right? That's going to be our wavelength. That's going to be our emission of light energy. So this is gamma. So here we have this symbol here. This represents gamma. So we know that gamma doesn't look like it changes anything. It just gives off some high-speed energy. So this is still going to be 14, 6, and C. It's going to look the same, but it's giving off that light energy. Now with this next one, we can see the helium, right? So that's going to be an alpha particle. And so if it's 134, it goes down by 4, it's going to be 230. And then this is 90, it loses 2, it's going to be 88. So we need to look on the periodic table, find out what 88 is, and it is radium. And this is, again, alpha particle.